Hello, everyone. My name is Yuying Zhou, and it's a great pleasure to talk about my recent CVPR 2024 paper, Learning to Bootstrap Robust Models for Combating Label Noise. Despite the success of the deep learning-based methods, they all assume that reliable ground truth annotations are abundant, which is not always the case in practice. This is because human annotations are inherently noisy. Further, annotations suffer from inter-observer variation, even among experts. This is one such example from our own collected medical image segmentation dataset, where a large portion of the pancreatic tail was missing from the expert level annotation. On the other hand, as the high capacity of deep neural networks enable them to memorize a random labeling of the training data, deep neural networks are potentially exposed to overfitting to noisy labels. In face of such challenges, in this work, we propose a method called learning to bootstrap for combating label noise. The bootstrapping loss is effective in noisy label learning as it leverages the model's own predictions to gradually correct mislabeled data. By balancing the true labels and the model's own predictions, it reduces the adverse effects of noisy labels, leading to more robust and accurate model training. However, for this approach, under different noise fraction, which is denoted by the NF here, the optimal beta is different. Another limitation lies in that this loss treats all samples as equally important during training, which could easily cause overfitting for biased training data. To address these above challenges, in this paper, we introduce a new versatile loss function that allows dynamically adjusting the balance between true and pseudo labels, as well as the weights of individual samples. This adjustment of the weights alpha and beta is controlled using meta-learning based on performance metrics from a clean validation set. This metaset is used to evaluate noisy sample gradients and assigns more weight to those closer to the metaset's gradient direction. Notably, this method focuses on a versatile bootstrapping procedure, concurrently adjusting weights for labels and instances within a meta-learning framework, irrespective of the specific reweighting mechanisms. In other words, if we change the weighting mechanisms, the effectiveness of our approach should remain the same. Here, we show our results on different levels of synthetic noise. Our method can serve as a simple and effective plugin for a lot of other learning with noisy label methods and consistently improve upon these methods. Unlike previous bootstrapping loss, our method offers greater flexibility. It uniquely does not limit the weights to sum up to 1, allowing for more nuanced reweighting across all instances and labels. Our method is also effective even when eliminating the validation set or the metaset to be 0. Our method can successfully rectify the label noise by adjusting the magnitude of alpha and beta, and also can be well generalized to medical image segmentation under different noise levels. The results on clothing 1M again demonstrates the effectiveness of our approach under the real-world noise. A quick summary, our method provides a unique joint dynamic reweighting mechanism, enabling models to bootstrap themselves up and mitigating the impact of erroneous pseudo labels without discarding any noisy samples. It also unifies the sample reweighting across real observed labels and pseudo labels using meta-learning. Our proposed objective, a generalized bootstrapping loss, conducts implicit relabeling, leading to significant improvements without additional costs compared to the vanilla sample reweighting. Our method is also compatible with existing learning with noisy label methods, often necessitating few to even no validation samples, and is effective for various vision tasks under both synthetic and real-world noise. Thank you for listening. For more detailed understanding, please come to our poster or contact me through email.